In this screencast, we will be covering limiting reactant stoichiometry. In a limiting reactant problem, we are given a chemical equation. We have to determine if that equation is balanced or not. We are also given a specific amount of two different reactants. We have to find the limiting reactant, excess reactant, mass of product, and the mass of excess reactant after the reaction is complete. Let's take a look at a problem. The first thing we must look at is our chemical equation to determine whether it is balanced. In this case, our equation is already balanced. So, we are given 100.0 grams of sodium and 100.0 grams of iron oxide. Using these three things, we can find the answer to our 4 questions in a few simple steps. A limiting reactant is the reactant that determines how much product can be created. In simpler terms, if there are 2 boys at a school dance, but only 1 girl, 1 couple can dance while 1 boy will be left over. This leftover is called the excess reactant. In order to solve this problem, we must first look at one product. In this case, we will look at the solid iron produced. For the first step, we have the 100.0 grams of sodium. We multiply that by sodium's molar mass, which is 1 mole over 22.98 grams. Next, we multiply that by the mole-to-mole ratio of iron to sodium, which is 2 to 6. Finally, we will multiply that by 55.85 grams of iron per mole, which is iron's molar mass. All of the units in this equation cross-cancel except for grams of iron, so that will be the unit of our answer. After doing all the math, we will get an answer of 81.0 grams of iron. Next, we will repeat similar steps for our other reactant, iron oxide. We will start with our 100.0 grams of iron oxide, multiply that by iron oxide's molar mass, which is 159.69 grams per mole. We multiply that by the mole-to-mole ratio of iron to iron oxide, which is 2 over 1. Finally, we multiply that by iron's molar mass, which is 55.85 grams per mole. Once again, all of the units cross-cancel except for the grams of iron, and we end up with an answer of 69.95 grams of iron. In order to determine which reactant is limiting, we simply look at which answer is smaller, because that tells us the greatest amount of product that can be made. We find that the limiting reactant is Fe2O3. Therefore, the excess reactant is sodium. In this step, we also determine that 69.95 grams of iron is the mass of solid iron. Now, in order to find the amount of sodium that is left over after the reaction is complete, we must work backward using the product 69.95 grams of iron. We multiply this by Fe's molar mass and the mole-to-mole ratio of sodium to iron. Finally, we multiply this by sodium's molar mass. The answer to this equation is 86.35 grams of sodium, which is the mass of sodium used up in this reaction. Since we have to find how much sodium was left over, we have to subtract this number from 100.0 grams of Na, which was our original amount of sodium. Our answer is 13.65 grams of sodium in excess. In conclusion, we found that limiting and excess reactants use using stoichiometry and mole-to-mole ratios. We also found the mass of products by converting moles to grams, and finally found the mass of excess using the excess reactant and initial mass.